Okay, I think we're on, so we're going to hope we are. So, areas of shapes and conversion of areas. We're first going to talk about areas of shapes. Now, I know my areas of simple shapes. I know the area of a rectangle. I know the area of a square. A square is a rectangle, right? It just happens to have all equal sides, so it's still base times height. You know, some people like to say square is s squared or a squared because they're all the same size, so area is a squared. Why learn a different formula when one formula works for all rectangles, right? So just rectangles, squares, base times height. Base times height. Very easy. I know my, okay, so I know my shapes, a rectangle or a square. This is my base, this is my height. All right, so I know the area of a square is base times height. That tells me everything that's inside this box. Okay, I know the area of a triangle is, this is interesting, with a triangle, every triangle in the universe, and I mean in the universe, in the omniverse, every triangle is half, exactly half of a rectangle or a slanted rectangle, which is called a parallelogram, because they stay parallel. The opposite sides are parallel. But, so, watch this. If I just did this weird little thing here, this triangle is exactly the same as this triangle. They're identical. Identical. They're just upside down from each other, but they're exactly the same size. Every triangle on the planet, every triangle in the universe is half of a rectangle or parallelogram, right? Half. So, here's my base, here's my height, right? So, area of a triangle is base times height divided by 2, because I just want to divide it by 2 to find out what half of a rectangle is, right? It works on every triangle, even when they're not right angles. But I'm not going to go into that detail right now. And then the last one is circle. All right, the area of a circle, I think everybody knows this now, is pi r squared. Okay, so let's say these are all my simple shapes. And I know my areas of my simple shapes really well. And you guys now do too, right? You know these, right? You can do these.
No, we're just going to get that.
Right? But what happens when you have a bizarre shape?
Like a little layer.
Then you got to do something, right? So like everybody knows that those are, you know, how to figure out the areas of those. But what if you have something like this? Right? I look at that and I haven't a clue. I don't know the shape of this. I don't even know the name of this shape. Do you know the name of this shape? It's a right, whatever. Yeah, exactly. Whatever. So I can't do this without doing something. But I'm gonna put a little number here. I'm gonna say this is 5. And I'm gonna say this is 3. And I'm going to say, let me think here. Is that all we need? No, we need to know this. So let's say this is 8. All right. So I have that, and it's bizarre. I'm going to make it into one of my simple shapes by just putting a few dotted lines. This I'm bringing down. It's a 90-degree angle, coming straight down. By making a 90-degree angle, I am creating a rectangle. Right? A rectangle. And so I have now a triangle, a rectangle, and half of a circle. So all I have to do is figure out, so now I'm going to say, if I want to find that area, I'm going to do this. I'm going to say the area of triangle plus the area of the rectangle plus the area of 1/2 of a circle, right? So there we go. So area of a, let's figure out what we got here. This is 5. That means this is 5 from here to here. What's this got to be? 3. All right. Now what is this?
6.
From here to here is 3. From here to here is 3. So it's got to be 6. Okay, good. So now my area of my triangle, it's base times height divided by 2. 3 times 6 divided by 2. By the way, I'm going to make all these meters. All right? Meters. 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 So it's 3 meters times 6 meters divided by 2 plus the area of a rectangle. What would that be?
6 times 5.
Okay, 5 times 6. 5 times 6. Okay, and that's meters, meters, and then plus area of half of a circle. So I've got to do this, 3.14.
Gary, it says 8. 5 times 8.
Oh, thank you so much. I appreciate that. 5 times 6. Didn't I say 6 and I wrote 8? Jeez.
Yeah.
All right. And then, so pi r squared divided by 2, or times 1/2. Pi r squared, and r is 3, so it's going to be 3 times 3 squared, and it's going to be meters squared, right? All divided by 2. Because really, with that, when it says 3 squared, it's 3 meters squared, right? So think about it. We have 3 meters times 6 meters, which is equal to 18 divided by 2. 9 meters times meters, which is meters squared. Okay, plus 5 meters times 6 meters is 30 meters squared. All right, we have 3.14 times that. We'll say it's 42. 9.42 times 9. Who knows that? 81, 9,
I have a
or
calculator.
yeah, okay, 9.42 times 9, whatever that is. 9.42 times 9. 9.42 times 9. 9.42.
Okay.
9.42 times 9.
4 times
9. And then divided by 2.
Many steps. Wait. 3.14 times 9.
Yep.
Okay. Divided by 2. It's 14.13.
Okay, plus 14.13 meters squared, because that square is 3 times 3, but it's also meter times meter, which is meter squared. So altogether, I have,
43.13.
all right, I'll take your word for it, 43.13 meters squared. We just added them all together. That is the area of this bizarre shape. I just I turn a bizarre shape into a collection of simple shapes, find the areas of those, add them all together, and I'm done. It's really quite simple. So that's as far as I'm going to go on this. I think that's clear enough, isn't it? Do you guys feel that's clear enough?
Yeah.
Does that make sense? That's the trick, though. Turn any bizarre shape. If it's a bizarre shape, let's say it's something like this. Right?
Not that bizarre, though.
You turn, that's not that bizarre, right? By just putting the little dots there, you've created 2 rectangles, right? Or you could have put the dots a different way. You could have gone like this, and you could have said, oh, well, I'll have 3 rectangles. This one, and this one. Yes, Indu.
I just checked the one. It's actually 40.6.
Which one is?
The area of that
The
shape.
area of that weird
That
rounded
43 point.
pointy triangle thing. Yeah, that.
The rounded rectangle.
Oh, this whole thing? It's
Yeah.
40 point what?
48.6. I got 48.63.
So is this one wrong?
I think it's 30.
So yeah, so
no,
we'll,
you forgot to divide the 9 by. It's 30.
3 times 6 is 18, divided by 2 is 9. So that'd be 39, oh, you're right, 40, actually, that's going to be 39 right there.
But that's 53.
Plus. Yeah, that's wrong.
No. Yeah, it's 53.
So what is that? 39 plus 40. Okay, 53.
Oh no, I screwed up.
53.13 meters squared. Sorry, guys. So
only after
I was
I
just
screwed
using.
up.
I was trusting you, Sal. Okay. No, that's good.
You blew it.
Good. So whatever it is, you just make it into simple shapes, and you're home free. All right. Now, the reason I'm including conversion of areas with the shapes is because areas is different than what I've been doing so far with conversions. Before, we've been talking about like perimeters or something where it's change 14 inches to yards, or change, 2,100 feet to meters or something, right? But I'm not talking about feet squared, I'm not talking about meters squared, I'm just talking about feet or meters. With area, notice what we found out. With area, we're always, it doesn't matter any shape in the universe. If you're talking about area, it's going to be a unit squared. Meters squared, inches squared, feet squared, miles squared, kilometers squared, hectometers squared, right? I mean, anything squared. But it's going to be squared. All right? So let's see how you do that with a conversion. And I know some of you know this, but it's going to be good for everybody to know this. So let's say I want to convert, I don't know, we'll say 45, why don't we say inches? I want to convert it to centimeters. Okay, it's inches squared, sorry. Because these are, when I see inches squared, I know I'm talking about area, right? And I want to convert inches squared to centimeters. 45 inches squared to centimeters. My conversion factor, who knows it by heart?
2.54.
It equals 2.54 what?
Centimeters equal 1 inch.
1 inch is equal to 2.54 centimeters. Good. So that's my conversion factor. So I'm going to come back over here, and just like I've taught before, I know 45 inches, but instead of writing inches squared, anybody know what I'm going to do? Sal.
It's in inches, right?
Yeah?
So you're going to do inches times inches?
Inches squared is inches times inches, right? So I'm going to write them separately like that. Inches squared means inches times inches. Now I just do what I've taught you. I put a line underneath that thing and I put a 1. Not 1 inch, not 1 centimeter, not 1 anything, just 1. Right? And I go times, and I put my fraction line, and I know I have inches upstairs, right? I want inches where? Downstairs, right? So I remember that 1 inch over 2.54 centimeters is the value of 1, so I'm going to do it. But I'm going to put the 1 inch down below. 1 inch, and I'm going to put the 2.54 centimeters up above. And now the fun part, right? The fun part. You've got to remember to do the fun part. I noticed yesterday some people would do this kind of thing, and they decided they didn't need to write the units in. Sorry. It doesn't work unless you write the units in. That's the whole process. You have to write inches times inches, and you have to write centimeters here and inches here. You have to, otherwise you're lost. Guaranteed. You won't know what you're doing. Inches, cross that out. I'm going to cross this one out. Uh-oh. Now can I just multiply it? I'd have 45 times 2.54 inches, centimeter inch. I don't know, inch, centimeter. What's that?
Inch meter.
That's not going to help me. They didn't ask for inch centimeters. They asked for centimeters squared, centimeters times centimeters.
Inches.
So I still have an inch up here. That doggone inch, right? So I've got to multiply it times something. I want to go from inches to centimeters. I'm going to use the exact same thing. It's the same thing, inches to centimeters. I've got inches upstairs. I need inches downstairs, right? I'm going to use exactly the same thing. I'm going to actually do this twice. The same unit multiplier. That's called a unit multiplier. I'm going to do it twice. So I'm going to write 2.54 centimeters. Always write the centimeters. Over 1 inch. Now the fun part, you cross out the inch, you cross out the inch. Do I have any inches left?
Yes.
No. That is a good thing. I have now, do I have centimeters squared? Centimeter times centimeter is centimeter squared. Yes! So now I need somebody with a handy-dandy calculator. All right. 45 times 2.54 times 2.54.
290.322.
All right, that's good. And I'm going to write here, what's the units?
Centimeter squared.
And do I have to put it over 1? 1 times 1 times 1 is just 1. I don't need to write that, right? So that's my answer. So the trick with areas is you always have your units squared. So when you're converting an area, this is always true, when you're converting an area, you use your unit multiplier twice. Does that make sense? That's all you have to know. All right, that's it for the lecture for today.